All right, let's go ahead and dive into our problem of the day. Be sure to answer the questions I ask out loud and to try your best by thinking deeply about this new strategy. So what does our representation need to show? Say it out loud. Right, we know the area of the poster is 96 square inches, we know it has a width of 4 inches, and we need to find the length. So how could we represent if we know the area and length of one side but not the other? Say it out loud. Yeah, in the past, we've often thought of this actually as a division problem, right? Where we know the area and we divide it by the width, and that would give us the length. Okay, so to solve this division problem, we're going to try something new. We're going to try the area model. A lot of my students last year actually really liked it and preferred solving division problems this way. So for the model to make sense, we have to think about division as a multiplication problem with a missing factor that we're using to find the area of a rectangle. So what would that number sentence be? Say it out loud. Right, so it would be 4 times length equals 96, right? We know length times width or width times length. So this is the width, this is the length. When you multiply those two factors, you get the area. And again, we're going to think of division as missing factor multiplication, where we're finding the area of a rectangle. All right, great. So what part of our division number sentence that we had here actually becomes the area of the rectangle, and why? Say it out loud. Yeah, the dividend right here, this is already in this problem, is labeled as the area, but even if it wasn't, the dividend would become the area in the multiplication number sentence we're thinking of to find our quotient, because the dividend is the total, and the area is the total amount of space covered by the rectangle. So what I'm going to do, I'm going to draw us a rectangle to work with here. And then I'm going to write that dividend right inside it, because that's the area of the rectangle. All right, what about the divisor and the quotient? What parts of the rectangle do those become? Say it out loud. Right, the divisor and the quotient, those become the width and the length, because those are the two factors we're multiplying to find the area. Okay, so I'll label the width as 4, and then the length we don't know yet. That's what we're trying to figure out. All right. When we use the area model for multiplication, right, when we were multiplying with an area model, did we try to multiply everything all at once? And if we didn't, what did we do instead? Say it out loud. Right, we used place value, and we multiplied each place. And we're going to think about place value here too. What's the largest place value that we have here in our dividend? Say it out loud. Yes, 9/10. Okay, so let's think. What factor could we multiply our divisor by to get this part of the area, to get these 9/10? What could we multiply 4 by to get close to 90? Say it out loud. Right, 20, because 4 times 20 is 80. 4 times 30 would be 120, that's too much. So I'm going to add 20 here to my unknown side length. And then what should I do to show that 80 of our 96 has been accounted for with that first factor? Say it out loud. Sure, I could subtract 80 from 96, leaving me with 16. And what place value are we working with now? Say it out loud. Yeah, the ones. So I'm going to start a new section of our rectangle. I'm going to put 16 ones. Okay. What question should we ask ourselves to figure out the next part of our missing side length here? Go ahead and say it out loud. Yes, we're going to ask ourselves, what factor can we multiply our divisor by to get this part of the area? I went ahead and captured that thinking question here. Read it with me. What factor can I multiply my divisor by to get this part of my area? Okay, what can we multiply our divisor, which is 4, by to get this part, or 16 ones, of the area? Go ahead and say it out loud. Yeah, 4. 4 times 4 is 16. So I'm going to add 4 to our missing side length. And then take away the 16 that we just accounted for. So we have 0 left. All right, what's my final quotient? Y. Say it out loud. Yeah, 24, right? The missing side lengths were 20 and 4. So 20 plus 4 is 24. 24 times 4 equals my area of 96.